I'm sharing my screen. Let's see, this is the presentation we prepare for today. So actually, today we are revisiting one of the smart simulators that we presented almost 6 months ago when it was first launched, which is the smart simulator for Open Lab. So actually, this is a new product in our catalog, a new product line that we're developing. Actually, it's also motivated by the distance learning and COVID situation with all the schools closed. So we're finding new solutions to provide technical training to the students from home using these digital tools. So since we first presented the product, I mean, we have been publicating it on our site online, and we are providing also a demo version that is downloadable from the website. So the idea of this webinar is to show you, to talk again about the product, but show you how to register, how to download the demo version, and then Helmi will also do a demo of the software so that you have the look and feel of the software and you see how an experiment would work. So the idea is also when you have the recording of this presentation, that if you need a demo, you can actually show parts of the presentation so that people get a better look at the software when it's functioning.
Yeah, just want to ask, when you say demo, is it a full version or a partial version?
No, it's just a partial version. I mean, we are just unlocking, let's say, I think it's a couple of experiments from the first section, which is the study of the stator.
Okay, got it. Thank you so much, Mark.
Okay, no problem. So moving on, I mean, this is standard introduction we usually give with electric machines. So, I mean, electrical machines, it has been really historic, let's say, category of products or product line. And the machines that we have developed, I mean, can be found in a lot of labs around the world. And we have been developing several solutions for training engineers and technicians on electrical machines. I mean, you will find different test benches, such as the EM test, the MAC-E, or also for machine automation and so on. But one of our products that have been most widely accepted is the Open Lab. Since this is a lab to study all types of electrical machines. So it's not only a lab to study a certain type of machines, but it's a lab that it's open and where the student can compose or assemble any kind of machine inside the catalog. So we have, for example, 2 stators, 3 rotors, and by combining the stators and the rotors, we can figure out different types of machines to study. This is powered in low voltage, which provides the students with a very safe environment for carrying out their experiments. So this is a great solution, a propedeutic tool to study all types of machine in a very compact solution, and also providing the openness to see how the machine is constructed inside. So it's a very popular lab that we have in our catalog. So just a quick overview. So here we have the machines, we have the different instruments to measure the electrical, mechanical power, we have rheostats, we have also the power supplies, and so on. So these are all the components that are actually included in the hardware version of the Open Lab. So for instance, this is the Open Lab essay, the composition. So that now it's the frame version. So this is like the newest version of the Open Lab. And now, with all the situation that we're living around the world, we have to solve a big challenge. So how to provide practical skills and practical training on distance learning. I mean, usually distance learning is very good to do, for example, lectures, or to do, for instance, presentations such as we are doing now through Zoom or other tools, or mock rules and so on. So we have different solutions to provide courses, but there are very little solutions to provide actual practical hands-on training. For this reason, our Open Lab goes digital. So we have developed this digital version of the Open Lab in the format of a smart simulator, which is called the Open Lab SSEM, to actually provide the full experience of the Open Lab in a virtual, let's say, version. So the core of the product or the software is actually a simulator. So it's a simulator that creates a virtual environment where we can interact with all the components that we saw before from the hardware version of the Open Lab. So you will see different elements such as the machine, the brake, the different instruments, different power supplies, and so on. But the main difference is that our simulator is a smart simulator. So what makes our simulator smart is adding on different sections that come with the software. So for instance, we have the theory in the topic section. We have the contents with all the experiments. Then we can track the progress of the students, and we have the help and instructions online. So it's combining partial functionalities of an online e-learning platform with a smart simulator platform. So this creates a very complete solution for the technical teaching in a remote environment or hybrid environment. So to highlight some key features of the smart simulator, I mean, first of all, the students can work asynchronously. That means that each student can go at its own pace. And the platform provides all the instructions and the theory needed to perform the experiments. These are the same 45 experiments that we find in the hardware version. They are all in the virtual version. And this way, we can also have the exact behavior of the machine in the virtual environment. So the same experiment that they do on the virtual environment, then they will be able to replicate on the actual hardware when they get back to the lab. The other important aspect is that the platform validates that the experiment was done properly. This means it provides real-time feedback to the student so that he knows if he has done the connection properly, if the results that he is getting from the platform or filling the table with are correct, and so on. And the professor may follow the student's progress, so it has a tracking tool to see how well the student is performing. So it's divided into steps. So each experiment, like for example here, it's a standard flow. So the student logs into the platform, chooses a topic, accesses the theory experiments, then works on the assembly of machine, make the electrical connections, and do the measurements. And this is an iterative process that happens with each experiment. So the student performs the experiment, gets feedback. If the feedback is okay, he's allowed to move to the next experiment. If a connection or some error was done in the assembly of the machine, he will receive some feedback from the platform to actually correct the cabling or the assembly, and then move on to complete the experiment. So this is the iterative didactic process that is put into place. And the tracking of the student is done by the progress summary, where we can see how many tasks the student has completed out of the proposed set of experiments. So this is the quick overview of the structure of the software, and I'm sure it will be very clear once Helmi starts showing you the demo we prepared for you today. Before looking at the demo, I wanted to share with you the steps to download the free demo software. So the first step is actually to go to the De Lorenzo global website and go to the e-learning section. So as you see on the website, there is a link to the e-learning platform solutions. And once you click on that e-learning solutions, you will see the list of our simulators. Then you would need to select which simulator you would like to download and click on the download icon. Once you click on the download icon, you'll be redirected to a form, a digital form that needs to be compiled with the email and the simulator that we want to download. And in this case, if there is a promotional trial code or full license code, it would need to be inserted in this space. Once the form is filled, you will receive on your email a link to download the software and to access it in a demo version. So it's very easy steps to actually get access to the demo version of the software. And as I was saying before, the demo software gives the first experiment for free as a trial that does not expire. So this is the main way that we can share also the link for the demo versions, for example, with our customers or colleagues. Okay, so now we can move on to the demo with Helmi. So I will give him the control so he can share his screen. As usual, if you have any questions, please don't hesitate to write on the chat, and at the end we will have also a Q&A session if you want to, if you have any questions on the trainer.
Okay, thank you very much, Mark. Hello again, everybody. So now we start with the demo with a real. I will perform an experiment, and you will see clearly how you can manage the software. It is very, very attractive software, and includes a lot of experiments that cover all the types of electrical machines. Sì? La abbasso un po' allora. Adesso meglio? Sì. Ok. So I will okay. I will launch the software just a little bit. Schermo. Okay, this is the software. It is the OpenLab SSEM. When you launch the software, you will get into a window to log in. Okay.
Oh, just wanted to, I forgot to tell you something. When you receive the link to download the software, actually in the email that you receive, you will have your first login and password for the demo version. And usually it's the same address that you provided. So the address that you provided as email address will be your login and password that then can be changed. Just wanted to point that out.
Okay. So when you start the software, you will get into the main window, as it contains all the system in this case. As you see, you have on your right the supports of the electric machines and the support of the electromagnetic brake. You have all the instruments downside at your right, and at your left you have the stator of DC and AC machines, and under you will have the rotors, different rotors with the magnetic brake, with the block and rotation system, with brushes, with the electronic speed transducer, and the coupling joint, and magnetic probe, and brush holder. So all your system is in this main window. And you have the main part in the central part. You have the base where you fix the machines, and you have the shelves. Here is a frame with the 3 shelves. At the left, we have, as Mark said before, we have the topic. When I click on the topic, I have different topics, as you see. You can have basic concepts, induction motor, direct current motors, commutator motors for alternating current, synchronous machines, and then direct current generators. And downside, you have the experiment of each topic on the upper side. For example, if you click on basic concepts, automatically it will open the list of experiments at your left. In this case, we have 10 experiments, starting from the flux produced by the poles, in this case main poles, until the rotating magnetic field for one single phase rotating field. And when you start for each one, you have a different window. In this case, before starting with the experiment, you have the basic concepts of the topics of the chosen topics. In this case, the basic concepts. When you scroll, you have all the theoretical part for this topic, the basic concept. Then when you click on each experiment, you will have different steps to do them. Before starting to show you one detailed experiment, I have chosen a first one just to show you how you can wire, how you can set up and then take measurements. I will give you just an idea about all the units that we use in this smart simulator. For example, as you see here, we have approximately 5 per 4. We have 20 instruments here. For example, when you scroll the mouse on it, you have the indication on which instrument you have. For example, in this case, a CDC. In this case, oscilloscope, for example, just to show you something. And you can put, as you see, when you take an instrument, automatically it will indicate to you where we can fix it. Okay, so that you can do it downside here because it's forbidden. So you need to fix it exactly on one shelf in this case. By scrolling the zoom, you can zoom also scrolling the mouse. You can zoom what you have, and as you see, we have in detail the different models. In this case, for example, we have a CDC. It is a CDC power supply in AC and DC, as you see, 3-phase AC and DC. And you have different output by selecting on A or B. If you select A, for example, in this case, we have 32 volt, 14 amps and 24 volt, 14 amps on the AC, on the NDC. And if you choose B, you have different outputs. you have the switch to switch on and off the unit for each kind of outputs, for DC and for AC. So are separated. Here we have an oscilloscope, for example, 2 channels. As you see, you have the terminals for the 2 channels. We have the potential earth. We have also reset and freeze if you need to monitor something better on the oscilloscope. We have here, for example, starting rheostat and resistive load. We have 3 resistance here of 15 ohm with different terminals. It replicates exactly what we have in hardware system, exactly taken from our system. We have also the switch to select R1, R2, R1 in this case, 1 and 2, 1, 2 and 3, or open again all. So when when the switch is on 1, it means it is closed the switch 1. 1, 2 closed the both. 1, 2, 3 closed all the 3 switches here. We have also a starting rheostat here with the potentiometer to vary the value of this resistance. It arrives here at, as you see, at 3 ohm, total 3 ohm. We have here, for example, speed meter. We will see it later in our experiment. And we have also pole changing unit. This is to study the machine by commutating between 4 poles and 2 poles. So as you have, we have exactly the same model as we have in our real system. Changing again with this mouse, we can see here the power, here the supports for the machines, here the load cell, here the load cell, other instruments here, for example, downside. And on your left, we have also this is DC stator. It is the same system in our real trainer, the AC stator. And we have also down here different rotors. For example, this one is a slip ring rotor. We have the other one is a rotor with commutator. And then we have cage rotor. This is a brake, magnetic brake. This is for to block the rotor or to rotate also the rotor, used in some experiments. We have the encoder to fix on a support to read the speed of the motor. We have also the brushes, as you see here, we have the brushes for slip ring rotor. And we have also the joint to fix to machine. We have the magnetic probe to monitor the flux produced by in the windings when you supply the windings with the stator supplied and without rotor. And this is brush holders also for the DC machines, for exactly for this rotor with commutator. We get back again just a little information about the icons also on the right. We have 4 icons in this case. This one, the last one down, it is to go home again to see all the system on your front, as I did now. So when you change the camera, for example, the scene, and you need to get back again to all the system in front of you, it's enough to click on camera home and you will get back again to all the system in front. We have the help. When you click on it, you get connected to the website on cloud system that you have all the help in the system updated always. Here we have the progress of the student. We will talk about it later when we finish the experiment. And here we have the language also. You can change the language between different languages that we are updating now also the system. In this case, we have English, we have Spanish, and other language also. In this case, Hebrew also. So let's start. I want to show you better now just one experiment, because if we deal with more than one, it will take more time. So I have chosen exactly one experiment, one fast experiment with a little bit of instruments and a motor. and we will see how we can deal with the experiment. So I have chosen, for example, in basic topics, basic concepts, the experiment number 9. It is very very kind to see it, because we will see the flux produced in three-phase rotating field. Okay, so I click on it, and automatically I get into the first of 5 parts of 5 steps of this experiment. As you see in the first downside here, you have 1/5. It means the first page of 5 pages. So the first one, we have the explanation about which experiment you have chosen. For example, in this case, rotating magnetic field, three-phase rotating field, to verify the production of three-phase rotating magnetic field by means of three-phase current. Overview and instruction. So it indicates to you how you continue with this experiment. You will work on the experiment in 4 steps. The first step is to assemble the systems, then to wire the system, to set up the power supply and instruments, and at the end to get measurements. So one time you have this notices about it, you can start to assemble your experiment. In this case also, you have exactly what you need to fix on your shelf, on your frame, and which machine you need to use. Okay, so in this case, I have to put a CDC power supply 1, amperemeter 1, and voltmeter 1. So I get back again here to put them frame and starts again to put them. And exactly you need to put them at it is indicated here. For example, AC/DC PS1, I need to put it in this position. So this is AC/DC 1, I put it here. I need to select amperemeter 1 and voltmeter 1. So I need, this is voltmeter 1 and this is amperemeter 1. So I fixed as it is indicated for me here. Then I need to select the machines. In this case, there is AC machine stator and one magnetic probe. So in this case, I don't need this support. So I take AC machine. Automatically, it shows to me where I can fix it here. Then the probe, I need to put the probe inside. So to do this, I need to change also the vision of the system. I mean the camera in this one. With the mouse, I'm trying to do it. And I take the probe, put it down, put it here inside. Look, automatically it takes the position. Get back home again to see it if it's okay. Experiment. So I have finished to assemble the machines in this case. At the end of each step, you have the button to check if it is okay. Check assembly. As you see, it will open a new window here where all in green color, it means that all the units, the instruments and the machine was selected correctly. Okay, so if I close it, this one automatically will open at my right the next step. In this case, the wiring. As you see, we have the electric diagram of the stator of the machines with the instruments, ammeter, voltmeter, and three-phase output of my power supply. And then downside, you have exactly the wiring that you need to do. So in this case, as it is indicated in the electric diagram, you have U1, U2 connected to U5, U6, and so on, V and W, and then U6, V6, and W6 connected all together. Then we supply these windings passing through an ammeter and putting a voltmeter between 2 phases. So firstly, the image, the downside here, it is exactly what it is reproduced here. So I need to make this wiring I make zoom on my stator in this case. So as you pass the mouse on the terminals, automatically you have them highlights. Look. So you highlight U2 and you go to U5, automatically the wiring is created. And I can choose also my color. Clicking on it, I have the list of color down at the corner, and I select, for example, red one here. Also V2 with V5, I select another color, in this case, for example, blue, and W2 with W5, the same. And I leave it black in this case. So to make 3 different faces with 3 different colors. Then I need to put all together this terminal. So I click on U6, V6, and again from V6 to W6. And all I do it, for example, yellow. Okay. So now if I get back again, I can see, as you see, it is done as it is in this image. And I make exactly the connection of the stator as it is done also in this electric diagram. Exactly the 3-phase, to take here it is indicated second phase and the third phase of 3-phase output. Second phase to here, for example, I highlight this one. I keep it as in this case blue, I make it also blue. And then the third phase connected to W1 here. And I leave it black as in this case. Then for the first phase, I need to pass through a meter and put the voltmeter between the first phase 1 and phase 2. So L1, I go to my ammeter, red one, for example. Then from as you see, when I highlight, it will indicate to me also it is indicated ampermeter 1A minus. It means the terminal minus of the ammeter. So from here to here, again, I put it in red, for example. Then I need to go from this point to the first phase of the motor. Okay. From here. Okay. Also, I keep it all the first phase. I will keep in red color. Then the terminal, this one, voltmeter 1 V minus, I go to the second phase to read the phase between L1 and L2. And put it here as it is in blue to keep the same color. I keep it in blue. So if I open again with home position, I will see that I did exactly this one in this case. Then the last wiring to do is to connect the potential earth between the module that need to be connected. For example, in this case, we have the power supply and the stator. This one, I give it the green color. So I have finished everything. Let's say there's I jumped some wiring. Let's say, for example, the potential earth. When you need to cancel a wiring, it's enough to select it and to on the keyboard with cans you can cancel. So I have I didn't the last one. I didn't make the last one. For example, if I click on check wiring in this case, automatically look will appear now the right indication list with the last one in color white, but not all in green. It means there is something missing in the wiring. In this case, it indicates it to me exactly. You need to connect the AC stator ground with a CDC power supply 1. So I go again to this one and this one and make my connection with green color, for example. And then if I check wiring again now, everything is in green color. It means that everything is okay. So as you see, when you finish this step of wiring, automatically at the end, and when it is everything wired correctly, look how the wiring will become. They will become transparent to make more easy to monitor. In this case, it is not very important, but other experiment where you have to use, for example, 10 instruments and some displays on the shelves, there is some problems to monitor the values. In this case, it's not important, but when you finish this step, automatically it becomes transparent to not become I mean more simple also to follow everything. Okay, so especially when they are in front of the displays of instruments. So I close this one. Automatically will appear the next step about to set up the instruments and the power supply, because as you see, the power supply, it is we have two different outputs, DC and AC, and the instruments also can the display the instrument can read the AC or DC values. So I need to select also those to adjust, to set up those selectors. So it is indicated also here. Set the three-phase source AC/DC power supply 1 for a fixed alternated voltage of 24 volts, 14 amps. Okay, so I go here. I need to select exactly 24 volts AC. We are talking about AC. It is in this case DC in this other case. So I need to select 24 volts, 14 amps. So selector AB must be fixed on A. Okay, it is correct. If I put on B, for example, here on A, automatically when you change this one downside here, it appears exactly what we are doing. And to select AC, because otherwise, if you need DC, this output, you need to select DC. In this case, we have AC output, so the selector must be on AC. And until now, you don't need to put on. Look, when I scroll the mouse on them, two of them are green and one are red. What means that in this case you can change them, but in the setup step you can't put on this one, and an information automatically will appear. You're not able to change that input in this step. This one will be done in the next step, and I cannot change the other, so it becomes different in the next step, as in a real machine after. No, it's for safety of the machine, it is better to not change the different kind of output, or not change also the AC or DC. Also for the instrument, it is indicated set on the voltmeter and on the ampermeter the AC/DC selector to position AC. Okay, this one it is just on AC, and the other one it is on AC. Okay, so if I click now on check setup, and if everything was done correctly, it will appear always a list of different settings in green color. So I will arrive now at the last step of the measurement. So look, automatically when you are in this step, the displays display exactly 0 values, because we are at the beginning of the experiments. So we don't have anything here. We can start the measurement. If I close this one, automatically as in the previous one, it will appear the last step, 5 of 5. It is measurements. We are in experiment 9, measurements. So measuring the system variables and evaluating the typical characteristics of the machine in general, this one. So starting the system. What we will see in this case, I have chosen the rotating magnetic field. So I will see the probes with a magnet fixed on it, with poles, with north and south poles, rotating when I will supply the AC machines. So to put it exactly in a manner to see also it's not difficult also to select this to see it. It is enough to push the two buttons of the mouses, turn around the system, and then zoom on it to see it. As in this case, you can see also all the system with the values here also. We can see also, look, as I said before, now the selecting of A or B output or AC/DC it's forbidden in this case. Also for this one, it's forbidden because we are in measurement setup, measurement step. This one we can do it because I need to turn on the power supply. So we have chosen a fixed 24 volts 3-phase AC. So automatically, when I put on this one, automatically I will see on the voltmeter approximately 24-25 volts between phase and phase, and also the current in this case. So go to experiment again. It will open the same page. Activate the 3-phase source AC/DC power supply 1 and supply the star connected stator windings by setting the on-off switch to on. Read the values of the voltmeter and the ampermeter for alternating current measurements. The small magnet is simulated in a certain direction of rotation and it goes on turning. We will verify this point now. And then I will fill this table. When you have completed the measurements, you can press the open measurement table. It means this button. And to fill the table, if I click on it, for example, look, I will find a table with just it shows to me immediately that it will be the voltage, it will be 25 because the voltage is fixed in this case. But the current, I can read it exactly from the instrument by clicking on this label here. Okay, so now I can close this one. I can leave the measurement table where I need. Then I click on now. Look what happens. So I have 25 volt, as I said before, with 0.9 amps, and the magnet is rotating because it is 3-phase rotating system, rotating field. So as you see, it is very simple example. It is between the first basic concepts of the different experiment that you have, but it will give you also the possibility to understand how to use the systems, how to assemble them, how to wire, and then you will find in the when you study the DC, synchronous, asynchronous, and the AC phase machine, different, more complicated experiment taken exactly from our hardware system. So that replicate exactly our real system. So as you see, this magnet is turning because it is a 3-phase power supply. If I click on this one now, automatically it will acquire the value on the ammeter. Look, we have 25 volt as are indicated on the instruments. 25 approximately, and 0.9. When you turn on also your power supply, automatically we have chosen the A position, we have the light lit on A position. If I turn off again, I will 0 here and the system is stopped. On again, going on again the system. So when you finish here in this experiment, it is a very simple table with one value only. But in some other experiment, you have a list of values to some, and other of them is you need to calculate by a formula that will be indicated also in the last step of the experiment. Here you can reset again your value. Do you really want to reset the table? Yes. Automatically, I get back again to the main measurement table at the beginning. If I click again, I can load a file that I have saved before, for example, in this case. If I look on load CSV, it is Excel file. I can load. I have just made a lot of experiment in this system. That's why you see all the values are saved here with the different types of machines that I have studied. Or when you click on it here, you have the values. You can save also this one. You can save also here with basic concept, for example, because we have chosen basic concept, experiment 9 in this case. Or you can load as I said. When you click on the last one, delivery, automatically the system will stop and will get to continue on the next experiment. So for example, let's say I turn off the system in this case. Okay, I have finished my study. I have saved my my file, my data, and I need to click on delivery. I click on delivery. Automatically will become the wiring becomes as I had the wiring. Look, so I'm not more in measurement now, measurement step, and I go to the experiment. I start from the 10 experiment again. I have finished the 9 experiment in this case. If I go to my progress icon, I will see, for example, in this case, that is done in this date. Today we have 17/3 March 2021 at 10:18. I have selected the top basic concepts as topic, and I did the experiment number 9, rotating magnetic fields, three-phase rotating fields. And in the yesterday I did another one, for example, on February I did another one, and I have completed until now 5.5% of the total experiment. In this case we have 25 experiment, and it is indicated here the experiment done in a color hard color and light color yellow in experiment not done again. So this is the possibility to save your data, and if you need also, and it is saved also in cloud system, this one, as you when you need to make to continue your experiment on other PC with your login, you can do it, and you can see on the same time what you did before, and you can continue also from another PC, from another place, for example, to continue your experiments also. So this is about this experiment. I hope that was simple to show to you how the system, how you can use the system, and all the experiments are made in the same manner as I did this experiment number 9, but more complex in when you select, for example, induction, let's say induction motor, for example, and I need to study the parallel, for example, about, let's say, synchronous machine. We have exactly in synchronous machine, we have about 9 experiments. I need to take the parallel of the main system, and I need to make to assemble. When you start with another experiment, automatically there is in a window that indicate that ask you, do you want to reset your assembly? If you are just reviewing contest, press no. Otherwise, yes. Automatically will cancel everything, and you can start to make the new one. Look at the measurement units that you need to use. In this case, we have approximately 11 units, so you need to put them here, and the machine is complete in this case. So it is more complicated, and it will take time, this experiment, to do. For example, one like this, medium time, I think mean time will be half an hour to make everything, to connect to start to set up the system, because to set up also the unit seeds is very more complicated that I did before. And the machine also, if I make here check assembly, we don't have anything in the front of you as machine. you will have everything error to do. You need to assemble everything in this case. Okay, I think that is all for this demo of simple experiment, and it can that will was attracting for you for the system. I don't know if somebody of them had just tried the demo version and
Yes.
And did by himself what I did exactly one complete experiment. So please, if somebody
Thanks,
has some question about it,
very clear.
yes.
Very clear.
Okay.
I like it. Well done. I think that from my own point of view, it was well presented and clear. It's another opportunity that we are showing and we are offering to our agent as even end users. So I think that it could be as another sales opportunity that I think that in this period is really needed. So I hope that you have some questions, and I hope that the stimulation was okay, as even for your side.
Yeah, it's all very clear. It's very good. Very, 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 very good. Any other inquiry, Sir Edmond?
We can in the next future we can do something similar to